iKnow is a knowledge authoring tool for physiologic monitoring that's been produced at the University of British Columbia. Before we can talk about knowledge authoring, we need to understand what is an expert system. An expert system is a software application that reproduces the performance of one or more human experts. It consists of a process to gather and codify information to what's called a knowledge base. And this is the process that's performed by iKnow, the application we're discussing. It may have some ability to learn from new data that enters the system. And it will have some way of testing the rule base in the real world of the expert. The typical features of an expert system include an input, which in our case is input from the physiologic monitors, a series of if-then rules that are applied to these inputs, a process whereby one or more rules can be combined in a process called rule chaining. Once we have one or more rule that fires, this produces an output, and associated with the output is some explanation feature that gives information about why the specific rule has fired. The iKnow authoring tool has three parts: a list of possible inputs, such as static representations of heart rate or blood pressure, or dynamic representations, such as the heart rate is increasing or the minute ventilation is decreasing. These inputs, when combined with expert knowledge contained in the rules, using if and then statements, produce a list of possible outputs, such as hypotension or light anesthesia. We start with the expert knowledge, which is then captured in a series of patterns. These patterns can be demographic, such as age and weight, measurement patterns, such as heart rate or blood pressure, dynamic patterns, such as deviation patterns, which include dynamic changes in the input variable, represented as a percentage change or a number of standard deviations in change, or change point patterns, which use specific algorithms to detect when a trend in a particular variable has changed. These patterns are then combined in a series of if-then rules to produce specific outcomes, such as hypotension or light anesthesia. The outcome itself can be used as a pattern and combined with other types of patterns in a series of new rules to produce new outcomes. Once we have our knowledge base completed, which consists of a series of these if-then rules, we combine them in a script which is run in a real-time inference engine. The inference engine has the ability to trigger just-in-time information associated with each rule that fires. This is an example of a real-time expert system. The script file that was created in the authoring tool provides real-time clinical decision support. The unique features of this iKnow application is that it has been designed to be used by the everyday clinician who does not necessarily have expert programming skills or is not the knowledge engineer. It has a very transparent reasoning process. It facilitates collaborative rule development with the ability to import and export specific rules or series of rules. The scripts are designed to run in an open source inference engine, and the application iKnow is available for free on the internet.